Hello everyone. In this particular video, we will be discussing problems and simplex method. In this particular lecture, I will be explaining how to solve the given LPP problem in 3 variables by simplex method, particularly under minimization. We solve this problem by converting minimization to the maximization. Let us convert first minimization to maximization. How to convert this? I want to convert minimization to maximization means I need to take objective function, I need to multiply by minus sign. Then whatever I have minimized z equal to, I will be getting as maximum z. So how to do this means, when I multiply by minus z, minus minimum z, when I multiply with minus minimum z equal to maximum of z dash. This becomes maximum z dash equal to each and every term in objective function is multiplied by negative sign, minus x1 plus 3x2 minus 2x3. This is my objective function what I got after multiplying by minus. That means after converting minimization to maximization. Now I change the constraints. You know how to change the constraints? Since it's all inequalities, I need to make it to the equations by adding slack or surplus variables. To add slack or surplus variables, I should check the conditions whether I have less than or equal to or greater than or equal to. Here all the 3 constraints I have only less than or equal to, less than or equal to. Therefore what I need to do, I need to add slack variables to the left hand side of the constraints here. If greater than or equal is there means I need to subtract the variable, that becomes surplus variable, minus s1 minus s2. But here what I have less than or equal to, so I need to add a slack variable, that means plus s1 plus s2 plus s3 will be there. After converting 2 equations, how it will look like my subject to constraints? Subject to constraints will be 3x1 minus x2 plus 3x3 plus s1 equal to 7. I added a slack variable. So next one, minus 2x1 plus 4x2 plus s2 equal to 12. Next one, minus 4x1 plus 3x2 plus 8x3 equal to 10. For all x1, x2, x3, s1, s2, s3 greater than equal to 0. Even my newly added variables s1, s2, s3 also must be positive. And after adding the slack variables to the particular constraints, what will be there for me? I need to take same slack variables and I need to add to the objective function, but my originality of the objective function should not get changed. So what I am going to do, I will add the s1, s2, s3 with the 0 coefficients. That becomes plus 0 s1 will be 0 only, no changes in the objective function, plus 0 s2 plus 0 s3. Is it clear? Now what I will do, I need to form a initial simplex table. Initial simplex table. We form initial simplex table here. Cj, Bv basic variables, Cbi, x1, x2, x3, s1, s2, s3, solution and ratio. Okay? Now let us form a table. Here what I have here, I need to consider complete system here. Look at it, I have x1, x2, x3, s1, s2, s3 and solution and ratio. Ratio I will find finally. Now let me write a coefficients of x1, x2, x3, s1, s2, s3 in from the objective function and from the constraints. I consider objective function coefficients under the Cj. It becomes minus 1, 3, minus 2, s1 is 0, s2 is 0, s3 is 0. This is what I have. Minus 1, 3, minus 2, 0, 0, 0 are the coefficients of the x1, x2, x3, s1, s2, s3 from the objective function. Now basic variables. I need to consider basic variables as S1, S2, S3 because these are the zero coefficients newly added to the system. S1, S2, S3. Is it clear? Now, next we need to find Zj. After that we need to find Cj minus Zj optimal condition to check it. Now let me fill the table. x1 coefficient 0, s2 coefficient 0, s3 coefficient 0. Now x1 coefficient under the first constraint, that is s1. S1 comes in the first constraint. Under the first constraint, what are the coefficients? I have x1, x2, x3, s1, s2, s3 and solution I should fill it. This becomes 3 minus 1, 3, 1. No s2 in the first constraint, no s2 in the first constraint and no s3 in the first constraint. So I become it as a 0. We should retain as a 0. Solution is 7. Solution is 7. Now, second constraint, minus 2, 4. No x3 in the constraint, so this becomes 0. And no s1a, that becomes 0. S2 is available, that becomes 1. S3 is not available, 0. Solution is 12. Now, S3 I consider. That means third constraint. When I consider third constraint, minus 4. Coefficient in S3, 3. X3 coefficient in S3, constraint 8. S1 is not available, S2 is not available, S3 is available, so 1. The solution is given as 10. Now I need to find the Zz. And I told you how to find the Zz. 0 into 3 plus 0 into minus 2 plus 0 into minus 4, 0. Similarly, I now apply 0 into minus 1 plus 0 into 4 plus 0 into 3, 0. Similarly, I will be getting 0, 0, 0, 0. Solution also 0. Now I will go for Cj minus Zj. When I go for Cj minus Zj, minus 1 minus 0 becomes minus 1. 3 minus 0 becomes 3. Minus 2 minus 0 becomes minus 2. 0, 0, 0. Now check the optimality for the condition. What is the problem we are solving here? We converted minimization to maximization. So I am supposed to go for maximization optimality condition. What is my maximization optimality condition I have here means Cj minus Zj must be less than or equal to 0 for every x1, x2, x3 and s1, s2, s3 columns. Now look at it. Minus 1, 3, minus 2, 0, 0. 0, 0, 0, minus 2, minus 1 satisfies the optimality condition. But I have a positive term here, that becomes 3. So since I have one positive which is not satisfying the Cj minus Zj less than or equal to 0, I can't reach the optimality solution for this problem now. What to do now? I need to select the largest Cj minus Zj value. What is the largest Cj minus Zj value here? 3. The respective column becomes key column. Respective column becomes key column. And using this key column, I need to find the ratios. How to find ratios? Solution divided by corresponding key column value. That becomes 7 divided by minus 1 minus 7. Next, 12 divided by 4, 3. 10 divided by 3, 3.33. So, is it clear? Now what I need to do? I need to select the least positive ratio value from the system. Minus 7, negative sign, don't consider. I have only two positive values, 3 and 3.33. In this I consider least positive value, that becomes 3. Is it clear? So the arrow marks indicates that 3 corresponding variable x2 get inside the system. Corresponding variable for minimum ratio 3 is s2 go out from the system. That means this s2 is replaced by x2. You get that? Now after replacing that, I need to identify new values for entire system. Here we know that the leaving variable, that is minimum ratio row, comes as key row. Is it clear? This is key row. The intersection of key row and key column, the value is called key value. Therefore, here key is 4. Using key value 4, I need to divide entire row, key row. When you divide entire key row here, minus 2 divided by 4, 4 divided by 4, 0 by 4, 0 by 4, 1 by 4, 0 by 4, 12 by 4 I will be getting. Here minus 1 by 2, 1, 0, 0, 1 by 4, 0, 3 will be the new values. What we do means we will form the iteration 1 table. When we form the iteration 1 table, this row must be changed by dividing key value and remaining 3 minus 1 3 1 0 0 7 minus 4 3 8 0 0 1 10. These values I need to change by using the formula. What is the formula we have here? New value equal to old value minus key corresponding column value into key corresponding row value divided by key value. Is it clear? Now for 3 minus 1 3 1 0 0 7 and minus 4 3 8 0 0 1 10, I need to use the formula to get the new values in the iteration 1. Now let us form the iteration 1 table. Iteration 1 table I am forming here. As it is same, structure will be there. CBI, CJ, basic variables, x1, x2, x3, x1, s2, s3, solution and ratio. Is it clear? Now the coefficients of objective function will not get changes. So same thing I will give minus 1, 3, minus 2, 0, 0, 0. Here S1 as it is S1 because no change in that. Already I told you x2 is getting inside, s2 is going outside. So in place of s2, x2, the variable is 0, x2 coefficient is 3 and s3 as it is coefficient with 0. Now similarly I need to form zz and cj minus zz. Now look at it. My intention is to find the new values for S1 and S3 rows. S2 row already we got it by dividing by key value. What are we getting? Minus 1 by 2, 1, 0 and 0, 1 by 4, 0, 3. These are the values what I got it after dividing by key value. Now what I need to do? I need to enter new values for remaining values. How to find new values? By using the formula. We'll check. We find the new values for the first row. What is the first row I have? 3 minus 1, 3, 1, 0, 0, 7. Including solution. Now consider 3. The 3, for this 3 new values, need to find, you know the formula, old value minus key corresponding column value into key corresponding row value divided by key value. So consider the 3, come back, key corresponding column value, correct? Key corresponding column value for 3 is minus 1. Is it clear? So this becomes old value is 3 minus key corresponding column value is minus 1 into key corresponding row value. For this 3, minus 2 is the key corresponding value. Corresponding row values will exist in the key row. Key corresponding column will exist in the column. Key column values. Okay. So now, what is the key corresponding row value? Minus 2. Divided by key value is 4. When I simplify this, I will be getting 3 minus 1 by 2. After simplification, 1 by 2 minus into minus plus minus 3 minus 1 by 2. I will be getting as 5 by 2. Is it clear? This 5 by 2 I need to replace in iteration 1 table in place of 3. So next one. Next value I am considering as minus 1. Old value is minus 1. minus of key corresponding column value is same, minus 1 only for everywhere. Key corresponding column value is minus 1, key corresponding row value. For this 4 only will be the key corresponding row value also. We get that. This becomes 4 divided by 4. This gives you minus 1 plus 1 equal to 0. Next value 3. For 3 again, 3 minus key corresponding column value for 3, key is this, corresponding column value is 4, minus 1 into, for 3 key corresponding row value is 0 divided by 4, written as 3 again. So now next value is 1. And I go for next value is 1. 1 minus key corresponding column value is minus 1 into key corresponding row value is 0. 0 divided by 4. This becomes 1. So next value is 0. 0 minus key corresponding value is minus 1 column value into key corresponding row value, check it here, it becomes 1. So 1 divided by 4, answer is, now for 7 minus key corresponding column value is minus 1 into key corresponding row value. Key corresponding row value is 12 divided by 4. Answer will be 10. Answer will be 10. Now the first row I am going to replace by these new values. Is it clear? And similarly I am going to find now for second row. For second row, let me consider minus 4 first, old value. Minus 4 is old value. Okay, my new value will be old value minus 4 minus of key corresponding. For this also, key, this is 4 only, right? Key corresponding column value will be 3. Forget about the first one. Key corresponding column value for minus 4 is 3 into key corresponding row value is minus 2 divided by key value 4. So this becomes minus 4 plus 3 by 2. This becomes minus 5 by 2. Becomes minus 5 by 2. Now next value is 3. Old value is 3 minus key corresponding column value, of course for 3 also key corresponding column value is 3 only into key corresponding row value is not, key corresponding row value is 4 only. 4 divided by 4, I will be getting as 0. For 8, key corresponding column value again 3 only into key corresponding row value for 8 is 80. 0 divided by 4, answer remains as 8. Now next one, 8 is over, minus 3, minus 4, 3, 8 is over, now come back for 0. 0, I am changing for 0, 0 minus key corresponding column value is 3 only, because this is key corresponding column value for 0 is again 0 only. Key corresponding row value, key corresponding row value should be in the key row only. Key corresponding row value is 0 divided by key value is 4, answer is 0. Next again for S2, when I go for S2, 0 minus key corresponding value is, column value is 3, key corresponding row value I will find. I am finding for this 0, right? Key corresponding row value is 1. Key corresponding row value is 1 divided by 4. Answer is minus 3 by 4. Now 1 implies 1 minus old value. Key corresponding column value is 3. I already told you key corresponding column value is similar for everything. Key corresponding row value is 0 divided by 4. Solution will be 1. Now for 10. Now for 10 minus key corresponding column value is 3. key corresponding row value is what? 12. 12 divided by 4. 3 is 10 minus 9 becomes 1. Now what I do, I am going to replace my new values completely to my iteration 1 table. After replacing all the new values for S1 row and S3 row, I got this table. Now as usual I need to go find ZZ. How to find ZZ? 0 into 5 by 2 0 plus 3 into minus 1 by 2 minus 3 by 2 plus 0 into minus 5 by 2 0. Answer is minus 3 by 2. And again for x2 variable 0 into 0 0 plus 3 into 1 3 plus 0 into 0 0. Answer is 3. Here what I am getting again 0 into 3 0 plus 3 into 0 0 0 into 8 is 0 0 plus 0 plus 0 is 0 0 into 1 0 plus 3 into 0 0 plus 0 into 0 0. Next again 0 into 1 by 4 0 plus 3 into 1 by 4 3 by 4 plus 0 into minus 3 by 4 0. I will be getting as 3 by 4. Here 0 into 0 0 plus 3 into 0 0 plus 0 into 1 0. Now here 0 into 10 0 3 into 3 9 plus 0 into 0 1 0, that becomes 9. So now I will find the Cj minus Zj values. Minus 1 minus 3 by 2 of minus 1 minus of minus 3 by 2 will be 1 by 2. 3 minus 3 0 minus 2 minus of 0 minus 2 0 minus 0 0 0 minus 3 by 4 minus 3 by 4 0 minus 0 is 0. Now check the optimality condition. What is the optimality condition for my problem? Cj minus Zj less than or equal to 0 because I converted minimization to maximization. So check it. 0 satisfies, minus 2 satisfies, 0 satisfies, minus 3 by 4 satisfies, 0 satisfies. But 1 by 2 I have got again positive value here and it's also a largest positive value. Again I need to consider this. Still I did not reach the optimality. This 1 by 2 I am considering. Corresponding column becomes key column now. What is the corresponding column I have here? This becomes key column. So now using key column values I need to find the ratio values. Okay, now solution divided by key column value. 10 divided by 5 by 2. 10 divided by 5 by 2 when I get it I will be getting as 4. That means 10 divided by 5 by 2 becomes 20 divided by 5, that becomes 4. And 3 divided by minus 1 by 2. 3 divided by minus 1 by 2 becomes minus 6. Is it clear? Yeah. 1 divided by minus 5 by 2 becomes minus 2 by 5. Is it clear? Now check again least positive ratio value. Now look at it. My least positive ratio value is what here? 4. Is it clear? 4 is the least positive ratio value. So this 4 complete corresponding row becomes key row. So the intersection of key row and key column, the value is 5 by 2, it becomes key value. Now what I have to do means, again I found the iteration 2 table. How to form iteration 2 table we told you. So here what I need to do, take the key value and divide by entire row. You get that? That means take the key value, divide entire key row by the key value, I will be getting a new value here. And again for x2 and x3 I need to find the new values. After that we need to replace again in iteration 2 table. Before that we should know that this corresponds 1 by 2 largest Cj minus Zj corresponding variable x1 gets inside and the smallest ratios, positive ratios s1 is go out. So in place of s1, x1 comes with the coefficient minus 1. Replacing the new values which I found from the iteration 1 table for x2 variable row and s3 variable row, this is what I got. Is it clear? So now let me find the Zz. We know that how to find Zz. Minus 1 into 1 minus 1, 3 into 0 0 plus 0 into 0, 0. This becomes minus 1. Is it clear? Now, minus 1 into 0, 0. 3 into 1, 3 plus 0 into 0 becomes 3. So, next case, minus 1 into 6 by 5. Minus 6 by 5 plus 3 into 3 by 5 plus 3 by 5 plus 0. My solution will be 3 by 5. Solution will be 3 by 5. Next, minus 1 into 2 by 5 minus 2 by 5 minus 2 by 5 plus 3 into 1 by 5 3 by 5. Solution will be 1 by 5. I replace here 1 by 5. Now again minus 1 into 0, 1 by 10, this becomes minus 1 by 10 plus 3 into 3 by 4, this becomes 9 by 4. I am getting solution as 43 by 20. So I replace here 43 by 20. And minus 1 into 0, 0 plus 3 into 0, 0 plus 0 into 1 is 0. Is it clear? Now solution. Minus 1 into 4, minus 4 plus 3 into 5, 15 plus 0. Solution is 11. Now let me find Cj minus Zj. We find Cj minus Zj. Minus 1 of minus 1. Minus 1 minus of minus 1 becomes 0. Minus 1 plus 1 becomes 0. 3 minus 3, 0. Minus 2 minus of 3 by 5. Minus 2 minus of 3 by 5. This becomes minus 10 minus 3 divided by 5. This becomes minus 13 by 5. So you will be getting minus 13 by 5. 0 minus 1 by 5 minus 1 by 5. 0 minus 43 divided by 20 minus 43 divided by 20. 0 minus 0, 0. Now check the optimality condition. What we have optimality condition for maximization problem? Cj minus Zj less than or equal to 0. Check it now. 0, 0, minus 13 by 5, minus 1 by 5, minus 43 by 20, 0. All the Cj minus Zj values are 0 and less than 0. There is no single positive value. Therefore, we reach the optimality solution. The required solution now will find like this. x1, variable x1, solution is 4. x1 equal to 4. x2, solution is 5. And there is no x3, the only s3 is available. Since there is no x3, I can write x3 equal to 0. I can write x1 equal to 4, x2 equal to 5, x3 equal to 0 because no x3 in the system of basic variables here. So now how to find the minimization? We need to record what is the problem? Minimization of z, right? We convert it to maximum z, right? So that becomes, now solution can be written as maximum z dash equal to, this is the zj what we need to find. The 11 is your maximum z. Answer is, we should multiply the gain answer by negative to get back your minimum z. So minimum z equal to minus of maximum z dash. Is it clear? That becomes minus of 11.